This is Module 1. The second half, or really most of Module 1. That's for the sake of the video. You guys get what's it called again? What are those things at YouTube? Whatever they are at YouTube, this class and the other one are up. So the introduction lecture from last week is there if you need to go back and remember that stuff. So I hope you got a feel for what we're doing in here and what I expect. And again, the emphasis is on the learning. And so if you will look over these things, if you will go over them and do the homework, practice the problems. Sadly, a lot of chemistry is math. I shared with you my disdain for it, but it is what it is. If you will practice it, you will get it. You just will. And what you will do is learn how to do it, not memorize it. You will learn how to do it, so when you go back to refresh your memory on how to do these things, you'll see that it's not so hard. So that's the goal. We are learning something today that I mentioned to you in the intro too, that the class, in terms of the way that I test you, the class is not cumulative, but the material is. It builds on itself. And something we will do today called the factor label method. And guess what? Right there in page 2 of your terms. The factor label method is something that you, well, I'll put it this way. The first year I taught this class, I didn't emphasize it. I thought, just because I was taught a different way in terms of what we're going to do in a second, and that is manipulate the metric system. And I might also add, most of this stuff is, at least it should be, some kind of review for you. But I just moved decimals the first year I taught this class, and I didn't emphasize the factor label method. Well, as it turns out, as the course moves through, we use the factor label method over and over and over again. So, and in some of the hardest parts of this course. Nothing too hard that you can't get. I mean, again, I have no desire to scare you. I don't learn under stress. But the hardest parts of the course will necessitate that you have an understanding of the factor label method. The factor label method is just a simple little thing, but you need to be familiar with it. So I've emphasized it once. I'm going to do it again in just a second. But for the sake of getting going, last week I think we introduced matter. I think we talked about mass. Is that right? Let's go ahead and launch right into, did we define mass? You have mass down there, is that right? Mass, let's see. I'm going to the secrets here in your textbook to the back, page 557. That's the glossary. So when you struggle for a word, the textbook has a lot of splaining. When sometimes it speaks around things and doesn't define things as precisely as I would prefer. It's a fabulous textbook, but sometimes it does that. So, we go to the back and there it is for us. So mass is a measure of the amount of matter in an object. So would you write that down in your notes, please? Mass is a measure of the amount of matter in an object. You do, it's the notes. Yeah, you're right on the notes. Oh boy. The day just got better right there. All right. So let's look at units of measure. So I have given you the table on page 5 at the bottom of your notes. So you will always have it. You will have it for time immemorial. I bet you'll carry this around with you wherever you go once you leave this class, because you'll always want to know the units of measure, both in metric and in English. Yes, you will, won't you? All right, gram. The gram is the unit for mass in the metric system. All right? That's all we're going to define it as. The unit for mass in the metric system. Would you write that down next to gram? Unit for mass in the metric system. The Newton is the unit for weight in the metric system. We're going to define weight in just a moment in terms of it being a bit different from mass. But right now we're just going to run over these units. The slug is not necessarily a lazy person, as some of the translations of Scripture describe it. A slug is the English unit for mass. So we've got gram is the metric unit for mass. The English unit for mass is slug, SL. The meter is the metric unit for distance. And foot is the English unit for distance. Of course, you know there's yards and inches, but the unit that we're describing is the foot. All right. The liter is the metric unit for volume. And the gallon is the English unit for volume. Again, I trust that this is sort of reminders to you. There's nothing too big there. And in terms of these definitions, you're just being familiar with them, right? We're not doing anything with them yet. You're just becoming familiar. All right, finally, the second is both the metric and the English unit for time. Okay, it is the second. Alrighty, we'll look at that. We've breezed through the first portion of your notes. That's page 1 of your notes. Oh, that's better. Would you turn over to the second page of your notes? I promised you, and I thought I had it right there in the notes. You'd think after all these years. Yes, sir.
I'm sorry, I missed the page. Where are the notes?
You don't have them?
Need them?
I tell you. There we go. There's chemistry.
Okay.
Yeah, here's
That's a lot. I did not see the notes.
your vision is worse than mine. All right, so I mentioned to you that I was going to discuss the difference between weight and mass. So as it turns out, we just defined mass as, well, we did define mass. Yes, it is the unit of the measure of matter. Well, as it turns out, weight and mass in terms of Earth are synonymous. You measure weight and you measure mass the same way by stepping on a scale. If you're me and you step on the scale and you look down and you see, it's 140 pounds. I wish. Weight and mass on Earth are the same, but weight and mass on the moon are different. And the reason is, in terms of mass, you have the same amount of matter that you had here. Come on in. There's one left right here. How are you? And you are?
Aaliyah.
What's that?
Aaliyah.
I thought so. I'm glad you're here. We just finished page 1 of the notes. So if you need to get them, maybe ask somebody and they'll show you their stuff. So I'm glad you're here. All right. So, but if you're on the moon, your weight is going to differ because weight is a function of gravitational pull. Weight is a measure of the gravitational pull upon an object. And so, in terms of Earth, as I said, the measure of mass and the measure of weight is the same. It's what we understand here. but not so on the moon or anywhere else in the universe unless you have the same gravitational pull as you do on Earth. So, if you are asked a question sometime in your life, maybe in 2 weeks, if you are asked a question, would your weight be different on the moon or on the Earth? You would say, well, sure it would be, because weight is a function of gravitational pull. What about mass? Would your mass be different on the Earth or on the moon? And you'd say, no, of course not. Why? Because mass is a function of the measure of matter. Okay? Now, one thing I didn't do, and I know there's going to be thousands of them, so we'll just go one at a time, but is there any questions on what we just did? I'm glad to see you're consistent with all the other years. Yeah, nobody wants to ask a question. Maybe somebody will come along in a little bit. So, in terms of the material on the first page, so how are you supposed to do it? Are you supposed to memorize it? You do. But what you do is you go over it. You read over the materials, you familiarize yourself, you realize that really all we did in terms of asking you to write words for those definitions was an expression of the table at the bottom. All right? The table is a lot simpler, but you have also in words what their definitions are. So if you would be familiar with those things, you will be good to go, not only for the test, but in the ensuing weeks and months of the rest of the course. Because we're not going to use English units for the most part. That's just to sort of familiarize you with it. But we will be using metric units from here on out. Page 2 is illustration in point. So in terms of the metric system, as you were introduced to it, I'm sure some time ago, you've got these prefixes that attach to the units of the metric system in terms of gram and liter and meter. So the prefix to those 3 suffixes that describe again the units that we just introduced, just reminded you of: micro, milli, centi, deci, and then for the most part, if there is no prefix, then you know it's just in the 1 to 10s or 1 to 9s, gram, meter, and liter. Then there is deca, hecta, kilo, and mega. So those are the prefixes that tell you, again, units, but how many? All right? So a milliliter is 1,000th of a liter. All right? A centiliter is 100th of a liter, and a deciliter is 1/10th, and so on. And so a kilometer is 1,000 meters. All right? So what are you supposed to do with those things? You know, you're supposed to become and or remind yourself of them and just become familiar with them. How much is a hectogram? You know, if you're asked about a hectogram, to be honest with you, I can't remember any questions in this textbook that refer to hectograms. But some point in your life you might be asked about hectograms. So that's what it is. So once again, I have given you the table that's on page 7, for you to have for time immemorial in your notes, for you to be able to use on the test. But you have to be familiar with the table to be able to use it. See, that's how this thing works. You have to have practice through the homework in terms of using that table to be able to do the stuff that's on the test. So that's what we're doing. So here we go. Factor label method. And that is defined, it begins on page 9. In terms of what we're going to do, this method that we're going to use for the rest of the course. All right, it's very simple. It's just not. So a requirement of this course is algebra, but really not even algebra. It's just simple multiplication and division, addition, subtraction. Anybody in here cook? Excellent, excellent. You like to cook? I do a little, but I prefer my wife to it. She's better. That's why I look the way I look. But anyway, so if you've cooked, if you've done anything at all that requires a recipe, all right, for the most part, that's what we're doing here in chemistry. It's following steps. It's filling in ingredients in terms of steps, okay? There will be equations that will not be difficult equations. They might be lengthy, just like the steps of a recipe, but it's the same principle. You're filling in ingredients into a recipe or items into an equation, all right? That's what this stuff is, and that's what the factor label method is. Let me just read from what I've got to you in your notes and we'll explain it. So, in terms of the factor label method, the first thing you do is write the measurement that is known in fraction form, always putting it over the number 1. All right? So, whatever you're given, whatever you start off with, and you will see that this works this way throughout the course. There's something that you will learn, which is the hardest part of the course. I mentioned to you a second ago, or didn't mention the name, but something called stoichiometry. And stoichiometry still is not that hard, but it's a matter of filling items into a recipe or into the process of cooking. It's a matter of putting numbers into an equation and following the steps. Well, the first step is to put whatever they tell you you have over 1. All right? Very simple, right? The second step is to find the relationship between the unit known and the unit to be converted to. And so the way that the factor label method is being explained for this chapter specifically has to do with unit conversion. You will use the factor label method for other things as well, but it's the same principle. You are now, the second step is looking for the comparison. It's looking for the relationship between the numbers that you're going to solve for. All right? So I have given you in this example, I've got, say they gave you a number of grams to begin with, and you put that over 1. Then you look for the relationship that they're asking you to convert to. So the example that I put there in your notes is kilograms. And so the relationship of grams to kilograms is 1 gram equals 0.001 kilograms. All right? How about this? Could you have done it the other way? Could you have done 1,000 grams equals 1 kilogram? Well, of course you could. All right? They're the same relationship, right? It's just that one is expressing grams as a single unit, and the other is expressing kilograms as a single unit. All right? So you find the relationship between the two, and the third step is you use that relationship to make a fraction. And so in this instance, again, I started with grams, and we're solving for kilograms. And so in this instance then, kilograms will go above grams, and here's the reason why, the last part of what I've got in your notes. That when multiplied by the first fraction, you're going to cancel out the unit that you were given, the unit that is known, and replace it with the unit that is converted. So it's in black, and maybe red would have been a little more explanatory, but there's gram in the third point here has a little line through the top. That's supposed to be a strikeout. All right. But anyway, it's a G with a hat on it. All right. But anyway, so do you see there? If grams are in the numerator on one side and in the denominator on the other, they're going to cancel. All right? You divide grams into grams, and they cancel. And that's what you're striving to do. You're striving to solve for what they've asked you to do, and you've set it up to do that by putting grams underneath kilograms so that grams cancel, and when you do the little bit of math, you're going to end up with kilograms. All right? So one more time, I'm going to repeat it. Why? Because it's so important. If you get anything out of Module 1, this is what you got to get. You got to get the factor label method. You got to practice it. You got to recognize it when you're asked to do these conversions, and so you will be happy-go-lucky for the rest of the course. All right. So you're given anything in the world. You got grams in this instance. Grams goes over 1. But then you're asked to solve for something else. In this instance, you were asked to solve for kilograms. So I had 100 grams. I want to know how many kilograms that is. So it would be a 100 G over 1, and then you would simply describe the relationship. In this instance, we did 0.001 kilograms over 1 gram. We could have done 1,000 grams under 1 kilogram. It would have worked the same way, all right? But in this instance, we just did 0.001 kilograms over 1 gram. Then you do the math. Again, you multiply these things, and the way that you do fractions, remember, is you multiply numerators and you multiply denominators. And in this instance, grams are going to cancel. So 1 times 1 is 1, and in terms of the kilograms, you'd multiply 0.001 times, I think I just gave you 100. So you would end up with 0.1 kilograms in this instance. All right? Now, is there questions about this? Speak up now if this is an issue. Please do. Everybody's got it. Is that right? All right, well, here's the deal. If you don't got it, you've got my email and you got my telephone number on your syllabus. So holler at me, and I'm delighted to go through it with you until you get it. All right? Let's look at an example of this stuff. It's on page 9. Let's look at the bottom. A student measures the mass of a rock. It's 14,351 grams. What is the rock's mass in kilograms? So we basically just did the same thing. First thing you do is, well, it doesn't have to be the first thing. It was the second thing in terms of my little steps there. But they go ahead and they find for you the relationship. And the relationship is 1 kilogram equals 1,000 grams. So then you put the measurement in fraction form. Remember what you're given, and in this instance, they told you it's 14,351 grams. It goes over 1. Turn the page. And then you put in the relationship. And they did it this time the way that I suggested you could. They put 1 kilogram over 1,000 grams. So the only difference is you're going to have to do a division problem rather than just a multiplication problem. Because the other way, you multiplied 1 times 1 and you have an answer, and then multiply the other. You divide the 14,351 by 1,000, and you end up with what? 14.351 kilograms. Okay? We see how to do that? We're good? Aha! Yes! Yes! It's a question. Please.
Silly question. Okay, so since kilo is equal to 1,000 grams and it's 1,000 grams, it's the equivalent of multiplying it by 1, right?
I think I'm following you, huh?
Okay, so we're just multiplying it by 1, but we're doing it in a way that it says 1 kilogram over 1,000 grams.
Yes, exactly.
Okay.
And the other relationship is 0.001 kilograms over 1 gram. Same thing. You get that?
Yes.
Okay. And I know in terms of thinking it through, sometimes, I don't get it, but good. Thank you for the question. Yes! Second day of class and there's a question. All right. I'm going to go ahead and move on. There's other examples, but more complex unit conversions. I don't think I've got this for you in your notes, so I just want to address it. So let's just do it as an example, and look at example 1.3 on page 12. All right. The mass of an object is measured at 0.030 kilograms. What's the mass of the, what is the object's mass in milligrams? All right? So what they're suggesting here, and it is true, at least in one respect, it is a true statement that there's not, in terms of our little table there's not a direct relationship stated between kilograms and milligrams. It's just tens, so there is a relationship. It happens to be a million, all right? A million milligrams is a kilogram, all right? But they are suggesting that you can do instead a two-step process. And either one would work. If you want to go ahead and figure out the relationship between, put it this way, positive units and negative units, we could look at it that way, or below 1 units and above 1 units. Again, you can determine that for yourself, and in this instance it's a million, but the other way to do it is just to do the relationship twice, and that's what they do here. So they give you the relationship between kilograms and grams, that's 1 to 1,000, and then they give you the relationship between milligrams to grams, and that's 0.001 grams, or they could have done 1 gram is 1,000 milligrams. So what they do is the two-step process. They compare the 0.30 kilograms, they put that over 1, and they compare that to grams, all right? You've got kilograms over grams, so kilograms are canceling. I'm looking at the example on page 12. And then they compare grams to milligrams, which once again is 1,000 to 1, or in this instance, they've got 0.001 grams over milligrams. It's 1 milligram. They could have said 1 gram over 1,000 milligrams, but they didn't. They just wanted to show you the differences. And so you do that multiplication and division, and you end up with 30,000 milligrams. So all we did there is 2 steps. Well, 3 steps, or 3 equations, 3 fractions, if you want to describe it that way. But 2 steps to get to the unit comparison. Does that make sense? Does it? We okay? All right, this is good. If you guys are getting this, you're a step ahead, I tell you. This is excellent. All right, we're going to continue to hustle. Again, because, you know, we introduced in the Act so long last time. So, in your notes, derived units is really what we're talking about next. That's on page 13 and following. So, in terms of derived units, there are relationships that, after this class, you're not going to use this stuff. But it's important to understand how to use the factor label method in this instance, and it just kind of reminds you too. So there is the relationship between English and metric. All right, for distance, an inch is 2.54 centimeters. All right, that's how we're going to do this. An inch is 2.54 centimeters. Mass, 1 slug is 14.59 kilograms, all right? And then in volume, a gallon is 3.78 liters. So, you know, in terms of living life, you know, we can relate to some of this stuff, right? I mean, we've measured centimeters. Anybody live or gone to Canada? Anybody? So it's not miles per hour up there, it's kilometers per hour. And a lot of cars these days have both on the speedometer. So that one never was easy for me to get. You know, it's a good thing I didn't get a ticket while driving in Canada, but anyway. So that's the derived units there, and in terms of it, let's just do an example. Okay, that's volume. All right. Is there any questions about that? So. Let me do this. I've got the description of it there. Let me just continue on in the notes. In terms of derived units, right underneath the table there where I compared it for you. When adding and subtracting units, obviously you know the units have got to be identical when you add and subtract them. When you multiply them or divide them though, it's a little bit different. It doesn't matter if the units are identical. So if you were to multiply 3 kilograms by 4 milliliters, you could end up then with 12 kilograms milliliters. And that's an acceptable unit. So in terms, and we will see how this plays out as the course goes on. But if you were to divide 6 grams by 2 milliliters, you'd end up with 3 grams per milliliter. All right? So what I'm wanting you to get out of those statements is this, and that is that in adding units, you got to make sure they're the same. But when it comes to dividing and multiplying units, you combine them. All right, whatever they are. If they're the same, well then that's fine. But if they're different, you combine them. And that's all I want you to know at this point about that stuff. So if you would just be familiar with those 2 statements, adding units, they have to be the same, and multiplying or dividing them, they can combine. So if you're good with that, let's keep moving. We good with that? Let's look at something else that I know that you've looked at before. So the equation for volume is length times width. A hand. Yes, sir.
So going back to derived units, would you mind working through one of the problems where you were multiplying or dividing, or you were combining them? I didn't quite understand that.
Okay, what in terms of, you might take the mask down. Thank you, buddy.
I don't understand what you mean by when you're multiplying and dividing units, you can combine the units.
Okay, sure. Are you looking there at the bottom of your notes? Are you following that? On page 2?
I see, but I don't understand.
You don't understand? And at this point, really all I want you to know, and we will see how this works in the months to come. We're not going to get there yet, but we will see how this works. The only thing I want you to know is that when you have different units and you multiply them, all you do is combine them. Okay? That's all I want you to know right now. Okay? So in terms of doing a problem or anything with respect to that now, all I want you to do, if you see different units and it's a multiplication or division problem, you end up with both units as the statement. Does that make sense? Excuse me, as the answer.
Yes, sir.
All right?
So
Thank you for the question. That's 2, 3.
to piggyback off of his question.
Good.
I get a unit of like, tell me if this isn't what you were asking, but
Say it's kilograms and milliliters.
yeah, so if it's kilograms and like if I have 5 kilograms and 3 milliliters, how do I mush those together?
You do the math, whatever the math is. If it's 5 milliliters times 5 kilometers, it would be 15 milliliters kilometers. That's it.
And let's say I have 5 grams and 2 grams, do I just put the answer at 7 grams?
Yes.
Okay,
Yes. For now. Yes.
all right.
Absolutely. And as I say, we will use this stuff and in terms of chemical equations and the production of things, we will be using this. But right now, the only thing I want you to do is watch the bouncing ball with respect to units. Okay? Does that make sense? Thank you for the question, because I'm sure everybody else is wondering the same thing. Any other questions? All righty. Good. Now, in terms of your question that you just had, in terms of a cubic centimeter, who, well, you're too young to do this stuff, but maybe you've, you've got an animal or something, and you have to give that animal some form of liquid medicine, and the vet sent you home with a syringe, and you were supposed to give them 10 milliliters of something or 10 cc's of something. So as it turns out, the relationship between those two units is very similar. In fact, it's the same. The last statement on your notes, as a matter of fact, it's in terms of the discussion of this, is on page 15. A cubic centimeter, or in terms of this thing, a cc or a cm3, a cubic milliliter, is the same. And in other words, it's the same as 1 milliliter. The relationship that I have, that I want you to know, once again, is just this statement on the bottom of page 2 and in terms of your notes on page 15. And that's simply that 1 cubic centimeter, a cc or a cm3, is the same as 1 milliliter. And I just want to stop with that and ask you to be familiar with that, with those comparisons in terms of the units. As we use them, we will flesh more out with respect to it, but that's all I want you to know. All right? And that's the last statement. And I think we're going to make this if we can move on. But if you have any other questions, please let me know. And I forgot the graduated cylinder. I will bring the graduated cylinder next week to describe to you, to show you something that perhaps you've already seen, you likely have seen, and that is the meniscus in a graduated cylinder. Look on page 18. We're going to turn back one page in a second, but you have graduated cylinder there described. To define graduated cylinder, it is a vessel used to measure volume. So just write that down. A vessel used to measure volume. And notice in terms of the graduated cylinder, I can't believe I forgot that. All this other stuff in terms of remembering it. So the way you measure volume with a graduated cylinder is by virtue of the meniscus. All right? And the meniscus, who here has worked with a graduated cylinder? Everybody? Hardly anybody. Okay, yeah. We've got 2 people. Anybody else work with a graduated cylinder? That's why I got to bring it in. Oh my. So when you look at a graduated cylinder, the imaginary graduated cylinder that I'm holding in my hand, when you look at that thing, what you see is the amplified version of the picture there on page 18. It's a little crescent in terms of the thing. The liquid is higher, it appears to be higher on the sides of this thing than it does in the middle. And as it turns out, the way you read that, the way you read the measurement, is based on the middle. You are such a... Thank you so much. Take care. Yes. I'll have that back. So I'll bring the graduated cylinder. Remind me to bring the graduated cylinder next week, and we'll fill it with water and send a couple of them and send them around to show you. So, but the key is, in terms of reading volume, It's at the bottom of the little crescent. All right? So again, with this chapter, there's basic pieces of information I want you to get, and that's another one. All right? Sadly, we won't do a lot of lab in here. We'll do some. We'll do one at the end of this semester and then one at the end of spring semester. And we will use a graduated cylinder. You know, I wish we could do more, but we just can't, not with an hour lecture and that sort of thing. But the way that you read it is at the bottom of the meniscus, and that's what that little crescent type thing in the graduated cylinder is called, is the meniscus. Now, if you would, look at page 19, and we'll fill in two definitions. And I want to refer to a figure on page 20. Is kind of an interesting thing here, but accuracy and precision. So accuracy is defined as an indication of how close a measurement is to a true value. All right? Accuracy is an indication of how close a measurement is to a true value. All right? So we got football fans in here, right? Please tell me you're a football fan. Somebody's got to be a football fan. All right, thank you very much. So your team is driving and they're getting close to the goal line and they're close to a first down. And so it's fourth down and they've gotten, you know, certain distance, and you think it's a first down, and the other team doesn't think it's a first down. And so the way that this thing measures out in terms of whether or not it's what you want, you hope, if it's not, that the accuracy is not any good. But if you've gone the distance for the first down, the accuracy of your measure is the determining factor. So, you know, they use these sticks on the sidelines and they bring them out from the sidelines, and they measure from one line to the next, and that's where they put the initial spot, and they take it to the other side. The accuracy, how close they get to what really where the ball lies and where the first down line was, is an indication of accuracy. So if something is a foot long, and I've got a ruler that only measures, say, bless you, say 8 inches, I might be able to get to a good measurement on that thing, but maybe I won't. If I get to a good measure, if I accurately describe how large, how long, how much mass something is, then I have accuracy. However, precision is just a little bit different. In a thesaurus, they'd probably be described as synonyms, but in terms of our use, precision is an indication of the scale on the measuring device that was used. All right? Precision is an indication of the scale on the measuring device that was used. So if you measure something that is 3.5 feet long, and or roughly 3.5 feet long, and you want to duplicate that measure with something else, say you're cutting a piece of wood and you want the other piece of wood to be exactly the same length. So your measuring tool, if it's only measured out in inches, in other words, the lines on the thing is only inches long, you're going to have to guesstimate in between, unless it happens to fall exactly on an inch, but you'll have to guesstimate in between those inch markers in terms of how long something is. Maybe you can write it or draw it on your measuring tool, but if your measuring tool is broken down into 1/16 of inches, or as at least many rulers are, 32nds of inches. And likewise with the metric system. If it's only in centimeters, you don't have as precise a tool as you would if you have a ruler that's broken down into millimeters, okay? So the point is, the finer your measuring device, the more precise of a measurement you will receive. So again, accuracy is a matter of seeing what you have and accurately using your measuring tool, but precision is a matter of just how precise, same terms, your measuring tool is. So maybe I've muddled all over that. Does that make sense though, in terms of those two terms? Does it? I'll bring a ruler next week. I tell you. Look at the next page though. Look at the descriptions in terms of the arrow targets. I find that actually somewhat confusing in terms of the definitions that we're using. Precise but not accurate. And again, in terms of using the definitions a little bit differently, I guess that makes sense. Certainly, in terms of being precise in and around your shooting, yes. But the statement that that target reflects the measuring precision of what I'm suggesting to you is that's not the most helpful of figures. And I've had students in the past look at that thing and it's kind of messed them up with respect to the definitions of accuracy and precision that we are driving at. So yes, it makes sense. The third description here, both accurate and precise, I mean, and again, I get what they're driving at in terms of the distinction between accuracy and precision. The accuracy here has to do with getting closer to the middle than the first picture. You're further away in the first picture, but you have all your arrows in the same spot. So you're precise, but not accurate. But again, what I'm wanting you to remember in terms of just this chapter, we're not going to see a lot of this stuff in the future, is in terms of the distinctions that I want you to understand, is accuracy is a statement of how well you've measured, and precision is a statement of how well defined your measuring tool is. All right? Is there questions about that stuff? Boy, we have made it. We're just about there. In terms of significant figures, I'm not gonna mess with this on the exam nor in the rest of the course. You have notes there with respect to significant figures. You may read through it if you'd like. It's an interesting discussion, but I'm not interested in it for this course. Scientific notation in terms of, and also adding and subtracting with significant figures. I've brought some definitions out there for you. You can look through that. Is there anybody here who has not been introduced to scientific notation? Because again, this is math and it's fairly simple. It's again, in terms of scientific notation, the example on page 1.6 reminds you all you're doing is counting zeros from one direction or the other and describing them as negatives and positives. Look at a couple real fast to remind yourself. 20,300, writing that in scientific notation, you start at the decimal, which is, you know, next to the zero, and you count over to the last number. So you move 4 places and you end up with 2.03 times 10 to the 4th. I mean, that's what you do with respect to that. Excuse me, number E is probably a nice reminder. What you're doing there, since you're looking at numbers to the right of the decimal, is you go to the right and you count over 4 places over to 8.75 times 10 to the minus 4. So again, I would envision most of you have messed with scientific notation, and then in terms of multiplying or with it or adding with it, it's a matter of moving those zeros too. So if you have questions about that, again, there's never much time to go through it, but I've always assumed, and rightly so, most of you have been introduced to it. So if you have questions, please let me know. The last thing I wanted you to see, though, is the density equation on page 28. And again, this is something that I'm sure, were introduced to in an introductory biology course or somewhere along the line. But so density, remember what I suggested to you about equations. They're recipes, all right? And you fill in the ingredients in terms of what you're cooking. In this instance, you fill in the items in the equation. The density is simply defined as an object's mass divided by the volume of that object, all right? So that's what the equation shows you. P is density, M is mass, and V is volume. And for the sake of any of you who, in terms of your algebra, you don't like moving around the numbers in terms of the relationship of things, I've given you all three of the way that you would be asked with regards to the density equation. In other words, if you're given volume and density and they want to know mass, I've given you that equation, M equals volume times density. And if you're asked about volume, again, it's mass divided by density. So, and some of those things you will be asked about. They are simple multiplication and division problems so long as you track or follow the recipe. So if they give you something that is the volume, you plug it into the volume portion of your equation. If they give you mass, if they give you density. We hustled a lot. I hope that most of this is review for you. And again, if it's not, it's okay. And in terms of your homework, so we didn't get to do a lot last week. So, you know, theoretically, we should have finished half of the lecture last week so you could do half of the homework. And we didn't. So you also then will have more homework this week if you didn't do any last week. Here's my point. If you need an extra week to complete this homework, I'm glad to give it to you. I will bring your exam next week and send it home with you, but in terms of the homework, in terms of checking it, I'm probably going to wait for another week. I'll wait to check it, not next week, but in 2 weeks. All right? All right. Is there any questions about this? Yes, sir?
Is the homework in the syllabus?
Yes. Homework is in the syllabus.
Would you like us to scan it in and email it to you?
No, just bring it along, and I'll have you come up and just show it to me. Again, what I want you to know, I tell you, I got it in the throat today. What I want you to know is just the notes stuff. Read through the textbook to flesh out what's in the notes, but simply what I have for you in your notes. All right? Thank you guys. Have a great week.